The next step is to define the destination of each sample. There are two categories, normal and pre-dilution. Under normal, you pick the starting location on the plate and then define if the samples are to be run horizontally by rows or vertically by column from that start location. Since this is an extended run, you must also pick the station or plate for the balance of the extended run samples. The next step is the destination of those samples requiring diluent for a pre-dilution. The formatter allows the user to set the minimum volume that is to be transferred or pipetted. This value is set in the parameter screen. For this example, the minimum volume is set at 40 microliters. For illustration, assume the worklist volume is set at 100 microliters for all samples. A sample with a dilution factor of 10 would have 360 microliters of diluent added to a well in the pre-dilution plate. Later in the program, 40 microliters of the sample would be added to this dilution well and mixed. The pipetter template determines the pipetting function. After mixing the 40 microliters plus 360 microliters in the dilution well, then 100 microliters would be transferred to the prescribed destination well to complete the transaction. The formatter has 4 microplate locations, J, K, L, and M. For an extended run such as this example, 2 of these plate locations are used as destinations. That leaves 1 microplate for pre-dilution and 1 microplate location that may be used for incoming samples such as the standard and QC samples. The standard and QC samples may come into the program from 1 ml tubes in the 96 well format or from cryo vials in the S rack. The choice of which location to be used is at the operator's discretion. If the formatter is equipped with a cold nest, it must be on station J. It is suggested that L and J be used for destination plates. Station M be used for pre-dilution, leaving Station K available for inputting the standards and QC samples when desired. We have skipped over vortexing. As each type of sample is defined for source location and pipetting template, it may also be selected for vortexing. Vortexing is assigned by sample type. However, as the program runs, the samples requiring vortexing will be done last. Those not requiring vortexing will be done first. This is done to conserve cycle time, since there is lost cycle time at the start of vortexing and on the last sample to be vortexed. As the last step, the operator may select a volume override. This will cause all samples to be processed at the selected final volume in the destination well. Normally, the processed volume is a function of the method used and may not be assigned by the LIMS. This completes the transfer of the LIMS data directly into the formatter program. Prior to leaving this screen, the operator should visually scan the worklist for the following. First, is the type designation correct for all samples? Secondly, do the samples with replicates all have the same source location? For example, QC1 is QA1 in all places. Standard 4 is in QD1 in all places. Each unknown has only one source location. That location corresponds to the correct rack location. Another thing to check is that the destinations run consecutively as you have laid out. Lastly, check that the correct pipetting templates have been assigned. Clicking Next brings up the graphical layout of the destination plates. At this point, you have the opportunity to save the worklist setup you have created. In many laboratories, the LIM program has the same format. The only change is the specific sample designation. If the LIMS format is the same, then the worklist setup most likely will be the same. It only then needs to be recalled and not recreated. Save the worklist setup under a recallable name. The next step is to click Convert to Steps. You are then asked if you're going to run by barcodes or position. Click on the desired choice. If running by position, each specific sample must be manually placed in the location you have specified in creating the work list. Standard 1 must be in QA1. Standard 2 must be placed in QB1. The unknowns must be matched by the LIMS ID and the assigned well location in the SRAC or racks. The use of Tomtec's PSID can assist in that process. If all samples including standard, QC, blank, and the unknowns are barcoded, then they can be placed in the racks in random order. The formatter hand retrieves the next vial in line, reads the barcode, and accesses the LIMS with that barcode number for the processing data. In many cases, the unknowns will come into the program with barcoded vials since they must be tracked from a source external to the laboratory. However, the standard and QC samples are usually made locally and they may not have barcode identifiers. The formatter can run the standards, QC, and blank by position and the unknowns by barcode. However, as stated previously, if running by position, it is the obligation of the operator to place each vial in its designated position created by the work list. For this example, click Run by Position. Notice the Program Steps column on the right. This is the created program step by step. The first thing to be accomplished is adding diluent to the pre-dilution plate for all samples that require dilution. A single tip is loaded, and then the required diluent is aspirated from the prescribed diluent source, in this case RA1. The pipetting template to be used is indicated. Notice that starting at step 7, the diluent is dispensed into the pre-dilution plate at MA1, then MB1, MC1, as specified in the work list. However, the first sample, step 4, had 50 microliters dispensed directly to the destination well in LB6,